In this video, we're going to take a look at linear models and rates of change, kind of what that looks like in the terms of algebraic means and graphically what that looks like. Because this idea of rates of change and this definition of what we know as the slope is going to become hugely important when we move on to the next chapter and talking about how is the slope then applied to calculus. Why is it so important in the study of calculus and all that? So let's go ahead and get started looking at the definition of the slope of a line. Just like up there, we had the definition of a slope of a line, but let's go ahead and write it down. It's basically the definition for the slope of a line, we use the letter m to represent the slope, and that is the change in y over the change in x. Okay. Also, it looks like y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Either one of those is fine. Even if you look up here, they have a different definition, and this is kind of where we're headed to. So let's just go ahead and write that down. F of b minus f of a, and where a and b, those are your x's, right? So f of x minus f of x sub 1 and so forth. So let's write it like that, because that's how we get your y values. So if we do f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1, that's where the whole f of a, f of, I forget what they had up there, but f of b minus f of a all over b minus a, or vice versa. You could go f of a minus f of b all over a minus b. Doesn't matter. But also, in all of this, you cannot have a denominator of 0. So for example, let's look at this right here. All right, we cannot have them equal to each other. So x sub 2 cannot equal x sub 1. And any of these, this one as well, it would come here and here, because if they did, they'd cancel each other out and you get 0, and you can't divide by 0. All right, and then this one over here, b cannot be equal to a. Okay, in class we'll do that exploration, and we're going to try to do them without graphing all of them. Let's skip over that. Let's go ahead and look at the different equations of lines, two of the most important ones that you learned in algebra. We'll just quickly review the point slope form. It's exactly what it sounds like. They give you the point. So it's y minus y sub 1, and different books show it different ways, but this is always the way that I've used it, is equal to the slope times x minus x sub 1. And in this case, if they give you the point in an equation, and they also give you the slope, then you can write the equation. Okay, and all of this still comes from this equation right up here. Okay, because if you, in this case, if you divide out the x minus x sub 1, it comes over to this side, x minus x sub 1. Whoops, and then boom, you have the equation for slope. So right here is the equation for slope, because that cancels out. Okay, so the point slope equation is just the equation for slope rewritten. Same thing for the slope intercept. That's y equals mx plus b. Now the slope intercept is taking the point slope equation and going through and solving. So the slope intercept equation is when you would multiply this in, so you get, and then you would add the y sub 1. I know I'm doing a lot of right over here, but you'd have y is equal to mx minus x sub 1 times m plus y sub 1. But when it's a intercept, that is wanting to know the slope intercept form, and so we know that it's crossing over the y-axis, and so that x coordinate is always going to be 0. So this is 0, so that cancels this out, And the x sub 1, y sub 1 is going to be 0, y sub 1, which is why then this transfers to what we know as the slope-intercept equation. So it's all coming from the slope equation. Now, with parallel and perpendicular lines, just to remember, parallel, they have the same slopes. The slopes are equal. And then perpendicular, a little more to understand. Right? So if the slopes are perpendicular, we would say that they're opposite reciprocals. Okay, and the notation for that looks like this. So that would be the opposite reciprocal slope. And the opposite reciprocal is, remember the reciprocal, that's when you flip the fraction, you flip the ratio or rate, and the opposite is you change your sign. So if it's positive, negative, negative, positive, right? But this is what it looks like when you're looking for that perpendicular notation. And so that's what I'll use in this class. Go ahead and try this next one here, plot the pair of points and find the slope of the line. This one is 100% review, probably from pre-algebra even, a long time ago. So try this one, pause the video, try it, and then come back to see how you did. Take a look to see how we did here. Your equation for slope, right? Because then you can just plug your x and y in there, and it looks like, no, I did it right. So your y sub 1 minus your y sub 2, x sub 1 minus your x sub 2, and you end up getting -2. Now, I like to keep slopes as a fraction because slope is always defined as rise over run, so I always like to keep it as a fraction. So that's why I put -2 over 1. -2 is not an incorrect answer, but our slope is -2 or -2 over 1. Okay, so that's what we're supposed to do on this one. Go ahead and try this one. It says, given the point and slope, write an equation of the line and also give 3 other points that can be found on that line. So pause the video, then come back and see how you did. This one's kind of tricky. You have to kind of think about this one. So first of all, let's just start the problem. You notice they give you the point and then they give you the slope, right? So that means we're going to be using the point slope form, which is that equation right there. But then you look, okay, well, the slope that they give us is undefined. What in the world does undefined mean, right? Undefined, remember that's where the slope does not exist. It can't exist, so it's a vertical line. And all vertical lines are x equals. So in this case, it's going to be x equals x sub 1, and our x sub 1 is -4. So our final answer here is x is equal to -4. Moving on to ratios and rates of change. How are ratios and rates of change related? So pause the video and try to answer that question, and then also try to answer this question. What's the average rate of change? What does that mean? So pause the video, formulate. You don't have to write it down. There's really not much of that I'm going to write down other than talk about it. So think about what your understanding of ratios, rates of change, how they're related, and what is the average rate of change is. Pause it and then come back. So really, ratios and rates of change are related in the way that they both are exactly the same thing. So we'll put they are the same thing. Okay. A ratio is just a mathematical expression, and then the rate of change is kind of, it's using the concept or the content. Depending on the problem, a rate of change is the applied understanding of the use of a ratio. All right, and then the average rate of change, which we're going to be later in this in our studies here in calculus, we're going to be coming back to this idea of the average rate of change. Probably the simplest example is like if you're driving in your car from point A to point B. So here's point A, here's point B, and if they're 200 miles apart from point A to point B, well, listen, you're not going to be able to drive the exact same rate, the rate or speed from A to B. So because you have to speed up, you have to slow down. And so in that case, we would take the average rate of change, right? And then that would be just distance over time. Now that's different than the rate of change, because the rate of change means at any given point in time, what is your speed? So that's kind of the difference, because you could be going 70 miles an hour here, but average 65 miles per hour, right? If the speed limit's 65 and your average is 65, you could still get a ticket if a police officer catches you going 70 at any point between A and B. Right, so from that, write down your own definition, your own understanding of these things. This is pretty much all of calculus talks about rates of change. So it's very important that you have a solid understanding of what they are exactly. Now let's take a look at this one. I want you to, here's an idea, or here's an example of using rates of change and what does that mean. And it seems like a simple idea, and it really is, but the way that things are used conceptually can be confusing at times. So for example, each of the following is the slope of a line representing daily revenue in Y. So I'm going to highlight that. In terms of time, X, and days. Use the slope, which is given there, to interpret any change in daily revenue for 1 day increase in time. Okay, so try this one on your own. Try to write kind of what these slopes mean in terms of the given information. Pause it and then come back. So on the first one, the 800, the hard part is kind of wrapping your mind around what does that mean. All right, so, well, remember y equals mx plus b. And we're looking at the slope. So if we plug that in there, y is equal to 800 x plus b, that slope represents the change. And remember, I always like to write it over 1. So if we look at, it's the change in y, and the y is the daily revenue, over the change in x, that's the time and day. So it's $800 per day. That is what, in this case, the rate means. So that's $800 per day. So the revenue increases $800 per day. Same thing on this one. In this case, this is going to be $250 per day. And the last one is just going to be $0 per day. Right? Which, if you're trying to make money, it's probably not one that the number that you want to see. It's better than any negative numbers, but it's not the one that you want to see. Now let's just quickly go over a summary of all of the equations of lines that we've seen. There's 5, so 1, 2, 3, 4, 5. All right, there are 5 equations of lines. There's the general form, vertical and horizontal lines, so vertical and horizontal. There's also, we talked about in this set of notes, the point slope and the slope intercept. And the slope intercept. All right, so now what I want you to do is you're going to pause the video here in a second and try to come up with equations of all of those lines. Go ahead and pause it, and when you have them, come back and see how you did. All right, there's really not much to talk about here, just making sure that you can take any form and put it into any other form. Obviously the vertical and horizontal, not so much, but general point slope, slope intercept, make sure you can go back and forth on any of those. Now looking at parallel and perpendicular lines, if we've already talked about this a little bit, so we're not going to write anything down, but parallel and perpendicular lines, know how to identify them. And even though lines look perpendicular, make sure you know how to tell. You would find the slopes of this line and the slope of this line to compare them, and if they're opposite reciprocals, then they are perpendicular. So just don't assume because it looks like they are that they are in fact. So use their slopes to determine whether they are or not. Go ahead and try this one. Write the general forms of the equations of the lines passing through the point that is parallel and perpendicular to the given line. Over that one, I just realized that I completely forgot to answer the second part of this. Also give 3 other points that can be found on that line. I think I got caught up on the fact that it was a vertical line, but 3 other points that can be found on that line, since it's a vertical line, is really easy. Whatever they are, it's going to be -4 as your x value. Then pretty much anything you want to do here, you can do 252, you can do 1, or -12. Really any, as long as it has -4 in there. So that one was easy. Sorry, I forgot to go over that one. First of all, in order to make this a little bit easier, and we're not quite done here, you can see we're not quite done. But in order to make this a little bit easier, I went ahead and got y by itself. I know it says general form, but in order to solve for, to figure out what our new y-intercept is, there's different ways you could do this. But what I did is just set it up as y equals mx plus b, figured out what my slope was. And then here, this one was parallel, so it's the same slope. This was perpendicular, so it's opposite reciprocal. So instead of -1/1, it's +1/1. Plug that in, figure out what your y-intercepts are on both of them, and there you have it. But one more step here is to go ahead and get y and x on the same side. So right here, when you add an x to both sides, you would get x plus y is equal to -1, and that's your general form. And then also you're going to subtract x from both sides, so you'd have -x plus y is equal to 5. And so that's general form. Remember, the values in front of your x and y have to be whole numbers. They have to be integers, I should say, and they're both 1 and -1, so we're good. All right, we're done on that one. And that is it for these notes talking about linear models and rates of change, not chains.